Welcome to lesson 3 of this course. In this lesson we'll talk about importing data in Pytorch. Data is necessary in machine learning because it teaches our model how to make good predictions. Because how are we supposed to change the parameters without data? You can get data from anywhere today, from websites that give you access to datasets or by scraping websites, etc. Not all data can be beneficial in every case. If we make a classification problem, we would like to have labeled data so that our model learns the difference between the classes. Because how is our model supposed to know which image, for example, belongs to which class? Let's learn how to import data in Pytorch. Now we're on Colab. First we'll import data that we have access to using the Pytorch library. Then we'll import tabular data, then image data that we have on our system. We'll also talk about data augmentation and normalization. So first we'll import the necessary libraries. And as you see here, we've imported mnist from torchvision.datasets. And mnist is a very famous dataset that contains digits, handwritten digits, in images that are 28 by 28 pixels. So we give mnist the location where we want to download the data. We set download to true because we want to download the data, and we set a transform to tensor. Tensor is a transform that will take the images and make them and transform them into tensors, because images aren't tensors in the beginning. So we change them into tensors so that we can use them in Pytorch. This will then install the data on our device. We've downloaded the data now. Then we're going to call random split. Random split splits the data randomly into the lengths given. So here we want a training data set that has 50,000 images, and we want a validation set that has 10,000 images. The mnist dataset also has a test set that has been kept aside, but it isn't in this dataset object. Now we split the dataset into two parts. Now we're going to create data loaders of the datasets that we have. Data loaders are very valuable because they are iterables that allow us to see the data batch by batch, so we can train the model batch by batch. We give the data loader the training dataset, the batch size, and we set shuffle to true for the training loader. We set shuffle to true because we want the model in every epoch to see different batches. We also have a data loader for the validation dataset. We put validation ds, and we give it a batch size of the batch size that we have, 128, but we multiply that by 2 because during validation we don't need to do any computation, and computation takes memory. So now we've created data loaders for both the training dataset and the validation dataset. Now we want the test dataset. For that we're going to use mnist. We're going to give it the location of the files. We're going to set train to false because we want the test set, and we're going to set the transform to tensor. Then we're going to create a test loader, a data loader for the test dataset. We're going to give it the test dataset, and we're going to set the batch size to be double the batch size that we have for the training loader. Now let's import tabular data. Tabular data is data that's in tables. So we're going to create random matrices, random NumPy arrays at the beginning, and that's going to be our data. It's going to be a 512 by 2 array, and that's the inputs, and the targets will be 512 by 1. We're going to convert these NumPy arrays into torch tensors, and We used NumPy because mainly and very oftenly you'll find the data you have in NumPy arrays. So we convert the NumPy inputs into a tensor, and so is the target. Then we combine these tensors together in a tensor dataset. Tensor dataset combines the tensors that we give it, so we have one object called dataset. This dataset, now we can split it given the length here, and we split that into a training dataset and a validation dataset. We have a batch size here of 128, and we create data loaders. Now we might have images on our system that we want to import, and very commonly you'll find datasets in this hierarchy. We have a folder for the training dataset and a folder for the test dataset, and each class is in its own folder. So first we'll just download the dataset. You don't need to care about this code right here. It's just downloading the dataset. Then we create what's called an image folder, giving it the location of the data and the transform that we want to apply. Then we create data loaders of these trainings of these sets. The training set has its own data loader, and the validation data set has its own data loader, and it's very similar to the code above. Now, a very important topic is data augmentation. Data augmentation is applying different transforms to the data so that we can have data that looks different every time the model sees the data. This helps the model to generalize and be more general, and not just to be bit and not to overfit on the data it has. And to apply data augmentation in Pytorch, we can call tt.compose, and this will compose different transformations. So here we have a random horizontal flip, which will randomly flip images horizontally. Then we have a center crop. We give it the size of the tensor, the size of the image that we'd like. We want an image to be produced that has a size of 224 by 224. Then we apply grayscale, and we want the grayscale to be applied to we want the image to have 3 channels. Then we transform the image to a tensor. There are many transformations that you can use in Pytorch, which you can find online, and these transformations, i.e. data augmentation, are only applied to the training set, as the main point in data augmentation is to make the model more generalized. So it would be very useless to apply data augmentation on both sets, because it's designed to be for only the training set. Another important topic is data normalization. Data normalization is very important because it keeps the values of the input in a certain range, and that helps us helps the model train faster. So we normalize the data by subtracting the mean and dividing by the standard deviation across each channel. So we put the means and standard deviations in a variable called stats. Then we do all the transformations and data augmentation that we like. Then after we convert the image to a tensor, we normalize the images by giving it stats, and we put the asterisk here so that we don't need to manually put each element of stats as an argument. And we call inPlace, and we set inPlace to be true, so that we don't make a copy of the data and use extra memory. All we do is change the original tensor. So that's it for this lesson. Today we've learned how to import data in Pytorch. Next we'll learn how to build the model. See you in the next lesson.